All right, let's get right into it. As the system architects here, we want to give you a look behind the curtain at something we believe is a total game changer. We're talking about the fundamental engineering that separates a frustratingly forgetful chatbot from an agent that feels truly intelligent. And the secret, as we discovered, is all in the memory.
Oh, we've all been there, right? On the left, you've got AI amnesia. You ask a question, and 2 seconds later, the bot has absolutely no idea what you were talking about. It's incredibly frustrating. But on the right, that's where we want to be, an agent that doesn't just remember what you just said, but actually pulls from past experiences to figure out what you'll need next. Now, that's not magic, that is a very deliberate architectural choice.
So, this really became the core engineering question for us. What is the actual blueprint for that kind of intelligence? Let's dive into the architecture that we finally landed on.
The breakthrough for us was moving away from the idea of a single monolithic memory. Instead, we developed this multi-tiered system we call the Memory Trinity. It is the absolute foundation for maintaining a coherent, personalized conversation over time.
So, this trinity is made up of three very distinct memory types: short term, long term, and something we call episodic memory. And what's crucial here is that these aren't just three separate databases. No, they're in a constant orchestrated dance. Each one has a very specific job to do. So let's break down their roles. Think of short term as the scratchpad for what's happening right now. Long term is like the personal file, holding all the persistent data about the user. And then there's episodic, which is like an experience journal, logging the outcomes of past interactions. Now, this is where that architectural tension comes in. We learned really early on you can't just dump everything into long-term memory. The latency would just kill the system. You absolutely need that efficient, ephemeral scratchpad to handle the now without getting bogged down. Okay, theory is one thing, but the real test is how it performs under pressure. So let's run a classic flight booking scenario through this architecture and watch how these three memory systems collaborate in real time. Okay, so the user starts typing, but before they even finish their query, the agent is already at work. It pings long-term memory, that personal file, and instantly pulls a key piece of persistent data. This user has a global budget of around $2,000. That becomes our baseline constraint right out of the gate. Then the user adds a new detail: find me a morning flight. This is a classic task-specific request. It's critical for this session, but totally irrelevant later on. So it goes straight into the short-term scratchpad. It's actually designed to be discarded once the task is complete. And that's exactly how we prevent data bloat. And this is where it gets really cool. While searching for flights, this system also queries the experience journal, that's the episodic memory, and it flags a past event. This specific client missed a connection because of a tight layover in Tokyo. It's not just recalling a fact, it's recalling a failure. And that is what allows the agent to give genuinely useful advice, not just raw data. But here's the reality of it. Users are chaotic. They are never linear, which led us to our next big architectural challenge. What happens when the user is halfway through booking a flight and suddenly asks about hotels? You can't just drop the old context. That leads to agent confusion and a really terrible user experience. The solution is what we call our context management framework. Honestly, it's like the system's air traffic controller, making sure every conversational thread can land safely without crashing into the others. So let's walk through that process. When the user asks about hotels, the very first thing the system does is preserve. It packages up the entire state of that flight search and just sets it aside. Then it can fully engage with a new hotel query. And the moment the user says, "Okay, back to the flight," it executes the restore step, reloading that preserved context instantly. From the user's perspective, it feels completely seamless. And this is what we really want to drive home in this breakdown. This is not AI magic. It's not some unknowable black box. This is tangible engineering. It's all about managing data states with precision, grounded in real logic and code. Let's look a little closer at that short-term memory again. We call it an ephemeral workspace for a very good reason. Its temporary nature is a feature, not a bug. Wiping it clean after a session is absolutely critical for managing resources and keeping the entire system fast and responsive. And in the actual code, that state management is handled by a simple but incredibly powerful function: clear session. When a conversation ends, this gets called. It effectively resets the working memory, tearing down all the temporary data structures and preparing a clean slate for the next interaction. It's just an incredibly elegant and effective solution. Now, in complete contrast, long-term memory is all about persistence. This is the repository where we build that historical relationship with the user. It's the mechanism that transforms a generic tool into a personalized assistant that actually knows you. And that relationship is built and maintained through functions just like this one, Update Profile. Every single interaction that reveals a new preference, say an aisle seat or a vegetarian meal, is an opportunity to call this function. We're turning a momentary exchange into lasting, valuable, and actionable knowledge for the system. So, what's the key takeaway from all this? For us, it's that true AI intelligence is an engineering choice. It's built, it's not just discovered. And the Memory Trinity is the architecture that makes it possible. It's all about perfectly balancing the now of short-term memory with the facts from long-term memory and the experience captured in episodic memory. That's how you get coherence. Ultimately, this architecture does a lot more than just help an agent book a flight. It creates a system that can genuinely learn from its own successes and failures. And that leaves us, as the people building these systems, with a much bigger question to think about. What does the future of collaboration look like when your partner system not only knows the facts, but truly remembers this shared experience?